In graph 21.4, we concluded that in the presence of a positive externality, the market produces too little. In chapter 19, we saw a simple policy that gets markets to produce more than they otherwise would produce: subsidies. We'll investigate here how subsidies that are inefficient in the absence of externalities can become efficient when there is a positive externality. Just as in chapter 19, we can use the market demand and supply curves to illustrate what happens if a subsidy is imposed. Our goal is to use a subsidy to get the market to produce XB rather than XM. We'll succeed if we can get the price that sellers receive to increase to PS and the price that buyers pay to fall to PB. A per unit price subsidy that's equal to the difference between PS and PB will accomplish precisely that, as we saw in chapter 19. In fact, it doesn't matter whether the subsidy is given to consumers or producers. In either case, it appears as a wedge to the right of the equilibrium that would exist in the absence of the subsidy, with the higher price being the price that sellers receive and the lower price being the price that buyers have to pay. As we saw in graph 21.4, the reason that XB is the efficient quantity to produce is because social marginal cost crosses the supply curve at that quantity. And the reason that the quantity XM is inefficient is because it gives rise to a deadweight loss triangle that lies immediately to the left of the intersection of the social marginal cost and the supply curve. Under market production, in the absence of the subsidy, the equilibrium price is PM, and consumer surplus is the area above that price up to the demand curve, the area A plus B. Producer surplus is the area below the market price down to the supply curve, or the area C plus D. And for each output that's produced, an externality benefit equal to the difference between the social marginal cost and the demand curve is produced, for a total area of E plus F of external benefits bestowed on the market output level, XM. In the absence of the subsidy, overall surplus is therefore equal to A plus B plus C plus D plus E plus F. When the subsidy lowers the price that consumers have to pay to PB, consumer surplus increases from A plus B to A plus B plus C plus G plus K. Similarly, when the subsidy raises the seller's price to PS, producer surplus increases from area C plus D to area B plus C plus D plus F plus I. Because output under the subsidy increases from XM to XB, the external benefit increases from E plus F to E plus F plus H plus I plus J. The subsidy therefore increases consumer surplus by C plus G plus K. It increases producer surplus by B plus F plus I. And it increases the external benefits for society by H plus I plus J. But the subsidy also costs the government money. It costs the vertical distance of the per unit subsidy times the amount that's transacted under the subsidy, XB. That gives us the rectangle B plus C plus F plus G plus I plus J plus K, which is a cost and therefore has to be subtracted from the benefits that are produced under the subsidy. Taking the increase in consumer surplus, producer surplus, and external benefits, and subtracting the subsidy cost, then leaves us with an overall increase in surplus from the subsidy of area H plus I. This is precisely the deadweight loss triangle we concluded exists under market production XM, a deadweight loss we've now recovered through the introduction of a subsidy. Such a subsidy is called a Pigouvian subsidy, and it's an efficient subsidy despite the fact that it distorts prices. In the absence of externalities, price-distorting subsidies create deadweight losses, but in the presence of positive externalities, the market produces too little, and so introducing just the right Pigouvian subsidy will allow us to reclaim a deadweight loss that would exist under market production.